Right, I'm going to show you how to put the firmware into one of these clock kits that uses a one of those long thin chips, STC 15. I've levered the chip out, shoved it in a bit of breadboard. I'll come to that in a moment. I'll just explain what we're going to do first. So to program these, all you need is a serial chip, USB to serial. Now this sort works well. I've also tried some of these and they turned out to be fake. So although they work as a serial port, they won't work for programming this chip. Now they may not all be fake, but I bought a few of these. So I can use them for other jobs, but not for programming these chips. And I've got some of those, and I've got this one that's a different colour, but it's the same long thin chip, same pin out. That doesn't work either. So as I say, that one works. If you get a USB to serial interface and you find it doesn't work, try another one. They're only £2 or £3, you know, a few dollars on eBay or whatever. If you've got an Arduino, like an Arduino Uno or a Nano, that'll have a USB to serial interface built in, so you can use that. All we want is something that will give us a source of power, can be 3.3 volts or 5, and a transmit and a receive line. Okay, so how to connect them up to the STC 15. It's very easy actually. The STC chip, it's a long thin chip with its notch up at that end. All the interesting pins, let's just focus in a bit more on this, zoom in a bit. The interesting pins for programming it are all at this end. That one on that corner, which is pin 14 I think, is VCC. And then this one, no sorry, I'm wrong about that. Whoops, that's ground. And this one, this 13 and 12 is VCC. So that's where you put the power on. And on the other side, so pin 15 is its receive line when you're programming it. So that's serial data in. And 16 is its transmit line, so serial data out. So in terms of where you connect them up to on your programmer, if this is your programmer here, I say programmer, your USB to serial interface, that's going to have a receive line. You connect the receive on that to the transmit on that. You connect the transmit on that to the receive on there. You connect the ground on here. Whoops. Ideally via a little switch or a jumper lead, because you'll want to interrupt it to ground on the chip you're programming, and VCC you can leave connected. You could interrupt the VCC line, but I found it's actually better to interrupt the ground to power down this chip, because you can get enough power leaking through the transmit and receive lines to keep this chip powered up even when you don't want it. Where I found if you disconnect the ground, then it does definitely reset it. So that's all you need to connect. You don't need any crystals, you don't have to link any other pins, anything like that. It's just 4 wires straight into the chip. Right, so next shot I'll show it wired up on a bit of error board. So here it is on the Vera board. This rail here I'm using as a ground rail. So this is the wire coming out of the USB to serial. So I can plug that in there, unplug it, and that will connect and disconnect the power. This blue wire takes the power into the ground into pin 14 of the chip. The red wire takes the 5 volts, I'm using 5 volts, so say 3.3 is fine as well, into pin 12 of the chip, and then the chip's transmit wire, which is pin 16, I've got on yellow, that's going to receive on the serial interface, and the chip's receive line, pin 15, is green, and I've got that going to transmit on here. So the next thing is to set up the programmer, which is very easy. I'll show you that next. Okay, so I've plugged the thing in now to my 15-year-old laptop, which is running Linux Mint, and I'll show you how you'd set it up to do this job. You can do this on Windows as well. It's probably easier on Windows, but what with Windows 11 this laptop won't really run it anymore. With Linux Mint, this is a fairly clean install, so there's not much on here at all. If you've not done it before, you have to add your user, I'll just zoom in a bit more on there, to the dial out group, otherwise the normal user on Linux doesn't get permission to use the serial ports. So the command for that is, I probably want to zoom in a little bit more, don't I? Hopefully you'll be able to see that. It's sudo usermod -a for add, capital G for group, name of the group, which is dial out, and your username, which on here is Martin. I've probably already done this, so I'm not sure what we'll get. It wants the password, and it's done it. So now it's just as well to test the serial port, find out where it is. It'll be on Linux, on Windows it'd be called something like COM12, COM13. You could find it in the device manager, or COM3 or whatever. On Linux it'll be probably be dev USB or something. So if we say ls for list / dev, what have we got? TTY, a whole bunch of TTYs that aren't actually there. I would imagine it's TTY USB 0, but I can't see it. Oh, I can, yeah, TTY USB 0, it is there, hiding amongst everything else. Right, so if you've installed some sort of terminal program, I've got GTK term on here, and tell it to use, if you've not got GTK term, you just do sudo apt install GTK term. We'll tell it to use TTY USB 0, and it's coming up with a load of rubbish, but we can ignore that. If I type something on the keyboard, we should see a little light flashing on and off on the board. Can you see that right down at the bottom? You might not be able to see it. Sorry, I'm being a bit rough with the camera. But hiding down behind the wires down near the board, when I'm typing now, you can see a little light just flickering, which is the transmit line. Well, that proves we got the right port. Sorry about the dicey camera work there. Let's get you back on the screen. So we finished with GTK term now. Close that. I mean, you don't have to do that really, but it's always nice to know that you're on the right serial port. So now we're going to install a program called stcgal, which is a Python program. And if you don't want to mess up your computer installing stuff you're not going to use very often, it's always a good idea with Python to make a Python virtual environment. Then you can install whatever you like in that virtual environment, and then it's very easy to just delete it, deactivate it, and then it doesn't affect anything else. So to do that, first of all we'll make a directory where we're going to put this stuff. So let's make one called, zoom in a bit again. So I want to make a directory and I'll call it stcprog. And then in there I'm going to use Python 3, which is installed by default on Linux things, but you might have to install it on Windows if you've never used it before. It's all free, and it's -m and then venv, because we're making a virtual environment, and the name of, oh, I should have changed, sorry, I should have changed into that directory that I've made. So I've done cd stcprog, and then I'm going to do, what was it, Python 3 -m venv, name of what we're going to call the environment could be anything. I'll make one called stcenv. I think that's it. Takes a few seconds. You only have to do that once, so if you're coming back to do this later, you'll have already made the environment. Then you have to activate it. So to do that, you'll always have to activate it if you switch the computer off. You tell it the source where you're going to run this script. Well, source is, you're saying run a script, and it's going to be in that folder. When you've done, let me just show you this. When you do that make venv, it creates a folder called whatever you've called it. So we're now going to run a script in there. So we say source, and the name of the folder, which is the name you gave to this virtual environment, and then it's the bin folder in there for binary, activate, That's what you're going to do. And the Python virtual environment is active now, and you can see whenever it is active it puts in brackets the name of the environment, parentheses perhaps I should say, in front of the prompt. So you can see it's saying open parenthesis stcenv and then the usual prompt. And then the first time you're using a virtual environment, we're going to use pip to install stcgal. It's always a good idea to update pip first. So you can use pip itself to use whatever version of pip is on the machine to upgrade the one in your virtual environment to the latest, because they keep changing it all the time. So you do pip install -- upgrade pip. And it may or may not update it. Let's have a look. Yes, it's saying that on this machine we've got pip 24.0 and it's upgraded it to 25.2. So you probably don't need to do that, but it's always a good idea. So you're going to need to do that once per environment you've created. Now we're going to install the actual program we're going to use. So it's pip install stcgal. Right, so that's installed it, set it up, ready to go. So now we can run it. So we just do stcgal, and it will probably find the right serial port. But if it doesn't, if you do stcgal -h, I think it is for help, it tells you all the prompts. So you can put -p and the name of your port. But I say if we just do stcgal all by itself, it's found the right port. It's asking me to cycle the power. If you remember, I put that little black jump lead on the board, so I'm going to pull that out, shove it back in again, and it's found it. Let's make this window a bit bigger. Perhaps I'll zoom out and you'll see everything that it's put. I just need to zoom out a fraction so you can see all of that. So you can see, you can't see yet, can you? Now you should be able to see it, I think. Yeah. So the first thing it did, it said waiting for MCU, please cycle the power. When I'd done that, it said done, and then it said protocol detected STC15. It's the model of the chip, which in this case is a STC15W408AS. There's a thing called magic, which is about the sort of serial numbers and things in the chip, and then how much code flash it's got, all sorts of stuff. The main thing is that by talking to it like that, you've proven that it's really there. So we're now ready to, we haven't changed anything yet in the chip, but we're now ready to upload our firmware to it. So I'll just copy the firmware into this same folder, and then I'll come back and carry on, show you how to actually flash the firmware to the chip. Okay, I've copied an extra couple of files to this folder now, this directory. So if we do ls, we can see that as well as the stcenv that was already in there, that virtual environment folder. We've got clock.ihx, led_test.ihx, which are Intel hex files. These are what stcgal knows how to write to the chip, and I'll be putting links to these in the description to the video so you can download them and do it yourself. So the command to burn one, let's do the LED test first so you can see it running something other than the clock. To burn that to the chip, it's stcgal as before, space, and then just the name of the file. So it's test.ihx. So again, it's going to tell us to cycle the power, and I'm going to pull out that little black link wire and shove it back in again, and then it finds the chip as before, and you probably saw a progress bar briefly there while it was uploading it to the chip, and that's it, it's done. So now I'm going to pull that chip out of the breadboard, shove it back into the clock kit, and let's see if it's doing something different. Okay, so I've put the chip back in the clock kit. Let's power it up. So it says in eBay briefly for initializing, which the clock does that as well. And then all this is a test of the LEDs. So if you press the right button, it moves it on a second. You press the left one, it goes back a second. If it goes back past 0, it jumps to 199, and that's because I used that feature in the time correction, because sometimes when it's correcting the time it can actually go negative, sort of. Anyway, that's an opportunity to show off that in my version of the multiplexing, when the LEDs in the last 4 positions of each minute, it doesn't make any of the other LEDs glow, unlike the standard firmware that comes with this clock kit. Okay, enough of that. Now we'll get back on and write the real clock program to the chip. So it's the same procedure as before, but I'll just run it through it again because the standard clock program's a lot bigger, so it'll take longer to burn. Right, chip's back in the breadboard. So this time we're going to do the same again, but burn the clock program. So instead of LED test, it's clock. And again, it's going to ask me to cycle the power, pull the wire out, shove it back in, away it goes. You can see the progress bar. That was uploading about 7K or so of code, and it's done. So we'll shove that chip now back in the clock kit, and I think we're virtually done. Right, it's back in now. Something I've done on this one, which I've probably mentioned before, is that if you tack some little wires on and connect them to a connector on the board, you can actually reprogram the chip while it's still on the board. So if you're going to be doing a lot of experimenting, that's worth doing. A bit fiddly. You see, you can pick up one of the signals from the one end of that resistor, and the other 3 you can get by soldering some wires onto the real-time clock chip, but it's a bit fiddly. If you're not good at soldering, probably easier to pull it out and shove it in the breadboard. Okay, let's get this powered up. So I've got a USB mini, is it? Mini lead there to plug in. That'll do for powering this. and I'll shove it into the thing, so we get INI, and there it knows the right time. Something I don't think I demonstrated before was in the previous video was the auto dimming on this is always active. You can't switch it on and off, so it dims the display down at night, stop it dazzling you. So to demo that, I can, if I cover up the sensor here, the light sensor on the back, I put quite a long filter time on it so that it doesn't keep flickering up and down. Probably need to use a bit of, I use the sleeve, my sleeve over it. That'll probably make it darker. Try that. There it goes. So you can see it goes down in about, I don't know, 10, there it's gone darker again. This camera always just makes it look like a colour change rather than actually getting dimmer. But anyway, if I take my sleeve away, you'll see it gets brighter again. There we go. I think I showed all the other functions of it off before. So there we go. I'll put links to download the two files in the description to this video. Any questions, stick them in the comments. If you try this, you've got no way of going back to the original firmware that came with the clock kit. So unless you can find that original firmware hex file online, or the source code and compile it, which I don't think I have yet, or you'd have to recreate it, which I haven't bothered to do yet. So if you do this, it's a one-way trip. Of course, you can always buy another clock kit. They're only a few dollars. Okay, thanks for watching.